Okay. Um,
ใช่ใช่ไหมตอนนี้อ่ากาแฟกำลัง develop first land
so I'm feeling more
แรกกำลัง
positive about
เก็บลง
this whole. Okay, just to be. Sometimes these
เงียบลง
these YouTube videos that I
ก็
do are
อีกประมาณ
probably a bit cryptic to people who are just arriving here
เราจะมีบท
randomly, which happens
สรุป
occasionally.
เพื่อ
So I'm working on this thing. If you want to see what I'm working on, this is the thing I'm working on. But then I'm then integrating it into my door as well.
อีกประมาณ1 วิ
That's
30 วิ
so I've just recently just sort of seen the guts of it working. So there's this problem of you have two separate processes that are running, and each of them has like a real-time audio thread within it,
สตาร์ทแท็ก2เสียง
and they need to communicate with each other using some mechanism, and it needs to happen really, really quickly. This is like fundamentally not a real-time safe operation, but we're doing some kind of communication here in a real-time audio thread. So we're breaking the rules a little bit of audio programming. Like audio programmers, sort of, we think of ourselves as being pretty damn cool, right? Because audio programming is meant to be this like it's a subcategory of real-time systems programming, except it's not really. Audio programming is like soft real-time. Um, but we all sort of like we have it drilled into our heads at birth as audio programmers that there are certain things that you simply can't do in an audio thread, like allocating memory or locking mutexes or doing system calls, for example. But you can't do this kind of interprocess communication without some kind of system call. And the nature of that system call is going to be different from platform to platform. So I'm working on Windows at the moment, so I've just implemented the first version of the Windows um, signaling. And there's two functions. There's three functions involved. I guess it is. The relevant ones are create event, which creates one of these event object things. Set event, which is like the signal, and then wait for single object. So both processes are doing wait for single object to wait for the other process to send them a signal. So I did this last night, just like an initial version, and it seems to work well. Just judging by the CPU usage. So I did like a couple like easier to understand, but like cross-platform and bad performance versions first, just to get to see it working, just to help myself understand. So the first one I did was like using the interprocess condition class from the Boost interprocess library. And what we would see there, so this is running now. So what this is doing is every audio callback, this is going to the sandbox process. This is like a debugging window that I have. Oops, I always forget that Windows does that. If you shake a window, it does that. So every audio callback, I think actually, what did I? Yeah, so the buffer size here is only, I think 64 frames, which is pretty small for this kind of thing. And it works fine. There's no DSP going on. All it's doing is, this is just testing, like, can I write audio to shared memory and have the sandbox process look at it and then send a signal back to say that, yes, it's finished processing. And the overhead of the signaling, which is happening here in the background, we can judge from the little CPU usage meter thing I have in the bottom left here. You can see it's basically nothing. I mean, this is acceptable. When nothing's happening, this is comparable to... And in fact, I'm in debug mode as well, and it's like hovering around 5% CPU usage. So with my... sorry. With the first like little experiment I did with the boost interprocess condition, whatever, if I used this for the signaling, this CPU usage would jump to like 100% because it was so slow. And then I did another experiment where I just implemented the entire thing using busy waiting. So both processes would just busy wait and they'd like yield in a loop. And that worked as well. That would have like really low CPU usage here. But then I'd look in the in Task Manager, I'd see like 30% CPU usage, which is obviously unusable. Because this CPU usage is basically, this is the audio thread. This is like an approximation of like how exhausted the audio time slice is getting. Like how long it's taking to, like if it's at 100%, that means we're basically missing the audio deadline. Basically, what that means, it's approximately what it means. Anyway, what was I going to do? Yes, I want to sort this out so that I don't want to end up with situations where so that's killed it. I don't want to end up with like sandbox processes like getting detached and then sort of continuing running in the background. So I want to have some kind of thing where they will detect if the client process is not responding anymore and auto kill themselves. I was previously doing that in the audio thread. Because basically when the sandbox process would wait for the client to signal them, when I was using the boost version, wait for signaled, I'd be using this wait for with a timeout. And then if it timed out, then yeah, I would terminate the sandbox process. That is not really going to pan out. And also, I just don't think that's a good way to do it anyway. I shouldn't do it in the audio thread. So instead, what I'm going to do is in the main thread, I will periodically send a message to the client just to say, hello, are you still there? And wait for a response. And if I don't get a response, then kill the process. And the audio thread might be like waiting infinitely for this signal to occur, and it won't do. So I'd have to like manually signal this. Which I think that will make sense because, or at least with the Win32 version that I've written here, it makes sense because these event objects, I think, are reference counted or something. So they'll exist until the final close handle. So yeah, oh yeah, the other point I was going to make is just that. So this, everything from here down to here, this is just the Windows implementation of this. But this is like the general interface that I'm going to have for all platforms. But we have to write a version of this for Linux and for macOS as well. But they're all going to have more or less the same interface. So I'm going to change this first of all because I'm not going to detect timeouts anymore. And in fact, stop requested, hold on. Oh yeah, so I also need to do the same thing for the client. Like if the client is waiting for the sandbox process, and then it crashes. With this implementation that I've done here, it's just going to hang because it's going to be waiting for an object that it's never set. So I need the client to set the event object itself at the point where a sandbox crashes. So actually, let me just remind myself the wait for single object. Wait abandoned. Oh, that's only for mutex, okay. So I'm not going to be using timeouts. I don't think that's the right way to do this. Wait failed, I suppose I have to handle somehow. So let's do this. So if result is wait failed, if it's not, then I'm just gonna assert yes. That. Now I'm gonna check this. If so we just return this. So I'm checking that the sandboxes did actually complete by the time I was signaled. If that's not the case, then okay, let's sort this out with an enum again, actually. Let's get rid of this. How does this work? So either signaled or not responding or stop requested. I don't want to say timeout because it's not technically a timeout. So the wait for sandboxes done result. Done. I'm not responding. How does this work? Okay, I think that makes sense. Oh, no, hold on. Let's just throw an exception. I think that makes sense. So if we get here, it means the client signaled this event object itself. And the only reason it would do that is if one of this sandbox processes crashes. Let me think about the case of multiple sandboxes. If there's multiple sandboxes and one of them crashes, okay. So all this means is at least one of the sandboxes didn't respond. Okay. Wait for signaled. Probably doesn't make sense to use a stop token anymore. Well, I guess it does. Okay. So this should just be not responding. If a stop wasn't requested and the client didn't respond, which is basically what this is checking, then it's not responding. Okay. Use a switch here so the compiler warns if I don't handle them all, since I keep changing this. Guess. Well, that's already gonna happen. Okay. Something like this. Okay, then... There's a lot of dust in the air because I'm preparing to move. I've been moving all my possessions around. This is actually fine. All I need to do is this, and then the next time around it shouldn't. I was going to say it shouldn't hang, but it might do because it might take a few frames for the audio thread to be updated with the updated model. But the client knows that the sandbox process has crashed at this point if this doesn't return done. It's just going to go right back into here. How do I deal with that? Don't actually know what to do. So if we return this, then we know one of the sandboxes is not responding, but we don't know which one. The main thread is going to pick it up at some point. So we're going to have to disable audio processing until we know. Okay, it's a bit complicated. So what I'm going to have to do is, in this situation in the audio thread, I'm going to have to set a flag, like an atomic flag, saying the audio thread doesn't know what's going on right now, so I need the main thread to sort things out for me. And until that time, the audio processing is just going to be disabled. So it'll be like, for a fraction of a second, the audio processing is just disabled until the main thread sorts everything out. Because the main thread knows what's going on, because main thread does its own check just check if all the sandboxes are still running. And if it detects one that's crashed, then it will update things. Okay, I get it. It's not that bad. It's not that bad. Is active. Okay, what if I do this? Standard atomic pool, audio disabled due to sandbox not responding. Set that to true. Turn false. Default. If group this thing okay, no, it should be called processing disabled, actually. And I can put it in here. So it goes into this disabled state, and then it's gonna just wait for the main thread to correct it. How does that happen? Basically happens every time I do this, I think. So if hold on, total nope, services, processing. Compare exchange. So if this is currently false, then set it to true. Is that the idea? Takes a reference. Because you're supposed to do this in a loop, are you? Let me just think. No, this is nonsense. Let's just do it normally. So, do this. Where else does this happen? This isn't actually correct though. This should happen after this has been published. This isn't necessary, I just realized. Okay, so the logic is when the main thread detects that a sandbox has crashed, That means the audio thread has already been hanging, waiting for it to be signaled, and it hasn't been. So actually, what we do is signaling. We just need to interrupt the wait. Just trying to think what to call the function. Maybe something like that. That will just help it escape from the weight. Get rid of this. Should do it. All we need to do here is return false. Yeah, okay, it makes sense now in my head. So I can simulate a crash by closing the sandbox. Okay, good. It's not hanging. Or is it? Maybe it is. I think the audio thread's hanging. Well, the audio thread's still running. But the shortcuts to stop the playback is not working anymore. Interestingly. I wonder why. Now what's it? Yeah, this is the audio thread's hanging, clearly. Yeah, it is. I can tell. Right. We should be getting here when the sandbox crashes. We do, actually. Then I think it goes straight back in here. The next time around, let's have a look. 0 active sandboxes, okay. Oh, huh. That makes sense.
Even though we got problems, we gotta find some way to solve them. I hope you come and follow me now and keep it on the positive. Even though we got problems, we gotta find some way to solve them. I hope you come and follow me now and keep it on the positive.
Okay, cool. That looks good. I have no way to restart the sandbox yet, but... So crash, simulator crash. And then we get that brief spike where it's like, what the hell is happening? But then it resolves it. That's cool. Okay. We're getting there slowly. There's a lot of fucking balls to juggle here. So what's next? Buffering I need to set up. Oh yeah, I need to get rid of this shit. I don't think I use this anymore, do I?